Hi, my name is Jillian.
I'm Steven.
My name is Jessica.
My name is Dane. My name is Tarek.
And we're the Carnegie Mellon Solar Racing Team. We're very happy to be able to return to Solar Splash 2024. We are really looking forward to racing again this year and implementing some of our changes that we've made on the boat. A little bit about our organizational structure. We have a management team, which is more so the president, vice president, which oversees the club activities, things like recruiting, meeting scheduling, and other logistical things like that. We also have our 4 sub-teams, which are our technical teams. Each of these project teams have their own project lead in charge of optimizing that part of the boat. Without further ado, here's a bit from our project leads.
Hi, my name is Tarek. I'm the lead of the power sub-team. What my sub-team does, what the power sub-team does is basically manage the entire electrical subsystem of the boat, from the solar panels to the George controllers to the batteries and all the wiring, cabling, and safety systems in between. We've also worked on getting new batteries in recent years, and more recently this year we purchased new solar panels and added quality of life features to the subsystem. An easier time at the competition setting up the boat, easier setup, easier changing modalities and wiring between the different events like sprint and endurance, as well as improving the performance of the team.
Hi, my name is Jessica, and I'm the propulsion lead of this year's Carnegie Mellon Solar Racing Team. As propulsion, my team works in getting the boat to move, in connecting our motors to our propeller. This way, we work pretty closely with the power sub-team, especially when it comes to optimizing our boat, given our boat's optimizing our motor, given our boat's electrical system. Last year, we used the Torpedo, which is an off-the-shelf electric outboard system. This year, we aimed to build our own by retrofitting an existing lower unit with a different motor and gear system, which we would fabricate ourselves. The reason for our gear ratios was because during the 2023 competition, we observed that we couldn't really adjust our system for speed and endurance races very well. So the hope is that with the adjustable gears, we could settle on different ratios for each competition through on-the-water testing prior to competition. And the gears would be swapped out between races on race day. So we began receiving materials in the spring and continued to work on machining and assembling the parts. However, as we were still learning about the design and manufacturing process, we weren't able to achieve this by the competition deadline, as well as test for optimal gear ratios. I do regret that we weren't able to finish our system and display it at the 2024 competition. In the meantime, we will use the Torpedo again, as we have had some familiarity built up with it from last year's competition. So come next year, I'll continue to take on the lead for propulsion, and we hope to continue building our own propulsion system for the 2025 competition.
Hello, my name is Dane. I am the sub-team lead for the Opti sub-team of Carnegie Mellon Solar Racing Team, and I'm going to be talking about our research throughout the year and our contributions and our final design. So our big research endeavor for this year was switching from a Raspberry Pi to an STM32. And an STM32 is an industry-grade microcontroller. It's much more low power, much more low computation power than a Raspberry Pi, but it's also going to be custom programmed. Its only purpose is going to be collecting data, and it's going to be a lot more robust than the Raspberry Pi and lower power. And in event of, for example, we run out of or we run low on battery power, we can run it more effectively than the Raspberry Pi. And it can connect directly to the acceleration sensor, our temperature sensor, GPS sensor, and current sensors, and it also communicates back with the Raspberry Pi, which still handles the display, since the display is going to be a higher computation task. We also switched from shunt resistors to also using Hall effect current sensors, which are less invasive. We can just place that around the wire instead of wiring in series using some sort of large resistor. And this allows us to measure, for example, the current going from the motor to the motor controller to see how much power we're getting from our propulsion, and also the current going to the batteries. But since in our final system we decided to use a pre-made motor or Torqeedo instead of our custom motor, we don't need these more complex current measuring systems since the Torqeedo has a lot of that built in. And so, since we want to have the most robust and simple system possible, we decided to use teammates' phones to collect acceleration and GPS data because the Raspberry Pi system has a lot of extra power. We don't want to risk it getting wet or anything. And so since we don't need the additional functionality of current sensing that we are able to have, we can just use the built-in sensors in a phone. But we still learned a lot developing our system, and we look forward to, once we finally get the custom motor working, connecting it all together and being able to control and monitor it.
Hi, my name is Jillian, and this year I was the president of the Carnegie Mellon Solar Racing Team, also known as CMSR, as well as the whole lead for the past 2 years now, actually. So the overarching goal that the whole team had for this year was to just improve the current boat that we have. So some of the surface level things that we did was just sand down the boat, redo the paint job, but more higher level things was to improve how certain components were adhered to the boat. And some things were quite literally just duct tape on the boat. But for this year, now that we had the foundation for a boat, we had a lot more time and flexibility to make things a bit more refined. One of the biggest things that we did for the boat was implementing stringers. I'll have a photo here, I think. So what these stringers did was they did a few things actually. So the first thing was they would provide structural integrity to the boat. The second thing was that they would help a little bit more with the weight distribution. Last year we found that the boat was very front heavy, so hopefully they would make it more centralized. And then the third part, which was the most important part for me at least, was it would make attaching components onto the boat a lot easier. Because last year we would have to drill holes directly into the carbon fiber exterior, but with the stringers now we can just drill things into that, which is also more disposable than the exterior of the boat.